All right, so once you have your A, K, D, C values labeled and you've wrote down your transformations, now you make a table of values to graph your transform function. And as I mentioned earlier, your mapping notation is x over k plus d and ay plus c. Now, in my example, what's my k value? Sorry, that's supposed to be a 2. So yeah, apologies. So k value is 2. What's my d value? -4. What's my a value? And what's my c value? -1. So my equation now is x over 2 minus 4 and -3y minus 1. What you do is you start from your parent function, take the values from your parent function, substitute them into this equation. For example, for my parent function, the first value is 0. Sub in 0 into here. 0 divided by 2 is still 0, and then minus 4. So my first value is going to be minus 4 for my transformed function. Next, you take 1, plug it in, 1 over 2. That's just 1/2. 1/2 minus 4. What's 1/2 minus 4? Yes, 3.5, negative 3.5. Plug in 4. What's 4 divided by 2? What's 2 minus 4? Minus 2. Now take 9. What's 9 divided by 2? 4.5. What's 4.5 minus 4? Yes, and it's positive this time because, it's more positive now. All right, let's do the points for y. Let's plug in 0 here. Negative 3 times 0, 0, 0 minus 1, negative 1. Plug in 1. What do you get? Negative 4, yeah, exactly. Plug in 2, what do you get? Perfect. Plug in 3, what do you get? Negative 10. So this is how you create your table of values for your transformed function now. So f of x, well, technically f of x is this one, so it doesn't really matter. And now you just graph it. You get a table of values. Sorry, you get chart paper, and then you graph your table of values. So -4. Give me a second, actually. All right, so we got our grid. Let's just quickly plot this then. -4, -1, -4, -1, boom. -3.5, -4, -3.5, -4, -2, -7, -2, -7, and then a half, positive half, -10. So it's looking like the function goes like this. Now this is important because the question is asking for domain and range. We know our starting point is here. How do we know that? Because that was the starting point of our parent function. Remember, we started from 0, 0. That was the first point of our parent function. So we know the function starts from here, and then it goes, and then it just continues the pattern. That being said, what is the domain and range? What do you think the domain and range is going to be? Looking at the graph now. Such that, okay. Just a reminder, the definition of domain is all the possible values for x. So what are possible values for x? Okay, so you're saying that x is less than -4? Less than or equal to -4? So what you said, just so you know, you said that -4, it's equal to that, and it's less than -4. So you're saying that function exists on the left-hand side of -4. Yes, so just be careful with that. And so x has to be greater than or equal to -4. Yes, because the function exists including -4 and on the right of -4. Perfect, so that's the domain. What about the range? Y belongs to all the real numbers such that y is what? Greater than or equal to what? -1. So you're saying that y is bigger than -1. So you're saying that, yeah, the function, so just be careful. Once again, the function exists below -1, not above -1. So definitely get better with that. And that's your domain and range. So that's how you do domain and range. That's how you do transformations. That's how you graph the transfer function. And then if you were to graph the parent function, I mean, the table's not there, but it was 0, 0, 1, 1, 2, 4, 3, sorry, 4, 2, I apologize, and 9, 3. This was what the original function looks like. Original parent function, and that's the transform function. So clearly we reflected it, and then we transformed it. All right, so this is the next question. Some transformations are applied to the reciprocal function, f of x equals 1 over x. So that's our parent function. These are the transformations. Very first thing I need you to do is label these transformations using the letters A, K, D, and C. So tell me what my values for A, K, D, and C are based off these words. Anyone you want to start with, I don't care. A would be 3. Look at your notes. That's what I asked you to take notes. Yes, A is 2. Perfect. K is 1 over 2. Wait, say that one more time. What's K? Oh, 1 over 3, yes. You got to speak up. Okay. Okay. Perfect. So let's see if you did it right. Here are the notes. So your K value has to do with obviously horizontal. And if it's a horizontal stretch, boom, it's 1 over whatever that value is. So you got it right. And if reflection the y-axis, that's here, makes K value negative. So yeah, you did it absolutely right. And then A value is vertical stretch, so it's 2. You 5 units to the right, D is positive 5, and 4 units up, C is positive 4. So absolutely right, perfect. Now we're going to write the equation for the final transform function. Do you know how to write the equation for the transform function? So go ahead and try it. Okay, so not a bad first attempt. Very close. So you have the correct positions for everything. The only thing is, look at our function. Is our function x? No, it's 1 over x. So that changes a few things. So we're going to go back here. This is our general equation. A comes first times the function, and in the brackets you have k times, and then another bracket x minus d, close bracket, plus c. Now the function f, how do I show this? Oh, I'll show you how to do that. Our function is 1 over x, so the correct way to do this is as follows. It's going to be 2, 1 giant bracket, and we're going to have 1 over, and k is being multiplied with x. So 1 over 3 x, and x is also being added to with d or subtracted. So in this case, it's going to be x minus 5, close bracket, and then plus 4 at the very end. So your k and d values are within the function. Your a and c values are outside the function, so they're not affected by the 1 over x part. But the 1 over x does affect your d and k values. So that's what you need to know. That's important. So this is what it would look like. And if you want to like simplify that fraction in the denominator, you can definitely do that.